In today's video, we will understand the concept of optional introduced in Java 8 with examples. Let's say we have a class student having a field name. Let's define its constructor accepting its name as argument. Also define a method that returns its name. Create a method in main class that accepts a name and create a new student object with this name and returns it. In the main method, call this create method with some random name. Assign it to a student object. Print its name using getName method. Run the program. Works fine. Now let's suppose this method fetches student object from database or some web service, but it fails for some reason and returns null. If you run the program, it will obviously raise an exception, which is null pointer exception. This is because the student object is null. A simple solution to make this program working is to add a null check and print some message in else block. This code, although works, looks very ugly. Secondly, wherever you call this getStudent method, you have to put these null checks. To resolve this problem, Java introduced the concept of optional. Optional is like a container that contains an actual object. It has methods to check if it contains the object or not, such as isPresent, ifPresent, and what you want to do if the object does not exist, such as returning another object with its or else method, throw exception with its or else throw method, etc. So, instead of returning an object directly, we return an optional. This angle bracket syntax tells that this optional contains this object. Now, instead of returning the object, we create an optional using its static off method and return it. We also need to change the receiving object as optional. To get the value or object contained in the optional, call its get method. This is the basic usage of optional. Now, we do not need this if-else check anymore. Again, there might be a situation that this object is null. In this case, the off method will throw a null pointer exception. Look at the source code. It mentions the same. To handle it, use optional's off nullable method, which will return an empty optional if the object is null. This will still work since the optional contains an object and it is non-empty. Now let me show you the problem when this object comes out to be null, due to which we decided to use optional. Let's set this object to null. Can you guess what will happen if I run this program? Will it work or not? It won't work. Instead of throwing null pointer exception, it throws no such element exception. The reason is when you try to call get method on an empty optional, it will throw this exception. Now we can simply check if optional contains a value using its isPresent method and then call get, or else we can print a not found message. But here comes a question that you may ask. This is the same as the initial if-else condition where we checked if student object is null or not. And what benefit do I get with an optional? There are a couple of benefits. First is that returning an optional from a method informs the caller that the optional might be empty and you need to handle it, which is different from a method that directly returns a value, since you might not always handle a null value. Second benefit is that when you get an optional, there are more elegant ways to handle empty values rather than if-else blocks. You have a provision to return a new object using its or else method. So, you can create a new object with unknown name and return it. Or else will return the actual object wrapped inside optional if it is not empty, otherwise return the new object. Print the name of student with its getName method. Run this. It works. You can also throw an exception if there is no point in creating a new object using its or else throw method. The no argument or else throw will throw no such element exception. But if you want to throw your own exception, then use or else throw with supplier argument. Assign it to a new variable. Since we are throwing an exception, we need to declare it. This is a lambda expression that supplies a value. If you are not familiar with lambda expression, then do watch the video link at the top right corner. One last point, you can directly get the value from an optional using its map method. You can pass a lambda expression to map. This lambda must accept one parameter and return a value. Map will return another optional. Calling get on this method will directly return the name, since we are passing get name to map already. Also, you can handle null condition by using or else and returning a default name here. Assign it to a string variable directly and print the string. Since the s parameter in this lambda is implicitly understood, we can replace it with this double colon syntax is called reference operator, which was also introduced in Java 8, and we will cover it in upcoming videos. So stay tuned and subscribe. And thanks for watching thus far.